This is Michael Saltzman from Blue Sky Bio. I'd like to thank everybody who's joining us for today's presentation. We are continuing today with the Everything Blue Sky Plan webinar series. As usual, if you have any questions during the presentation, please enter them into the chat box. And please remember to complete the webinar attendance form. The link is in the chat box as well, so we could send you the link. During our last live presentation, we did actually have a technical glitch with the broadcasting system. If that does happen again during today's presentation for whatever reason, I will post a new link in the chat box. You could click on the link and rejoin the presentation. It might take me a minute or two to set that up, but hopefully we won't have any issues and everything will be smooth sailing today. The goal of the Everything Blue Sky Plan webinar series is to take a lot of the clinical presentations that have been given in the past and to show how they could be done in the Blue Sky Plan software with a step-by-step process flow. The topic of today's presentation is Edentulous surgical guides. This is the 6th presentation of the Everything Blue Sky Plan webinar series. We've covered in the past topics including Introduction to Guided Surgery, where we discussed the basic of CT scans and the Blue Sky Plan software. Model-based surgical guide with the wizard. We discussed how to make a surgical guide using an optical scan or a CT scan of a model. The 3rd presentation was Impression Inversion surgical guide, how to take an impression, invert it, and use that to create a surgical guide. And today, in today's presentation, you'll see some reminders and connections to that presentation. We're going to touch upon some overlapping topics. The 4th presentation was using the normal mode of the software, features and functionality and powerful tools. Using the normal mode of the software, there's no reason or no need to enter any values or calculations or computations into the software. The software does everything on its own. We then continued to custom surgical guides, which was last week's presentation, where we jumped in more into the advanced mode on how to create a custom surgical guide if your drill kit is not included yet in the Blue Sky Plan software. Today's presentation is also going to be using the advanced mode, and we're going to get to that in just a minute. Recordings for these previous presentations are available via blueskyplan.com and also via YouTube. If you find that you don't know how to do something that I'm doing in the software today and I'm not explaining it today, then I do recommend to go back and check some of these recorded webinars where we cover those topics to provide a bit of a background for today's presentation. Like I said, it will be in advanced mode, so some of the features and functionalities we'll be using today have been covered in past webinar presentations. And we've released a new version of Blue Sky Plan around 2 weeks ago. Just to touch on some of the new features and functionalities, Ortho module is completely built into Blue Sky Plan with 2 jaw planning functionality. Continuing in Ortho, you have the ability to add a base for vertical printing. You have automatic bracket placement, and you're able to attach buttons. Everything can be exported. Currently, everything has been and continues to be free to export from the Ortho module. So you're definitely encouraged to go download the software if you don't have it yet and get started with your Ortho cases. In addition, continuing with free functionality in the new version of Blue Sky Plan 4.2.5, you're able to do a lot of different editing and model manipulation to different surfaces, such as CT and STL surfaces, such as cutting, such as adding a base, inverting impressions, converting CT to STLs, and all of that can be done in Blue Sky Plan and be exported at no charge. Okay, the cutoff is when you create a surgical guide. Once you create a surgical guide and you're going to be exporting that surgical guide, then the normal fees apply. But all of the manipulation of the CTs and STLs could be done and exported at no cost. We also have other functionalities such as the ability to now import a full color 3D scan, an OBJ file. We've added many implant libraries and guided surgical kits. So go ahead and download the software if you haven't yet. Today, During our presentation on Edentulous surgical guides, we're going to be discussing two different techniques for making the surgical guide, the dual scan technique and the triple merge technique. During the presentation, we'll also discuss other topics such as fastening pins, creating windows in the guides, functionality to align via prosthetic screw channel, analog models, and much more. Dr. Corey Glenn gave a presentation, Fullarch Guided Solutions, May 3rd, 2016. You can see that on the screen. It's got a lot of views, a lot of great content there. Today's presentation is going to be taking a lot of the clinical elements there and presenting the step-by-step process flow in the software. We're also going to be introducing some of the new functionality that we have in the software and how to incorporate it. But you'll see some of the screenshots and processes in terms of creating the physical models and preparation of the treatment plan will be taken from there, and some of the explanations regarding creating the denture and creating and prepping the patient will be taken from there as well. You're definitely encouraged to watch that original presentation. You know, patient's anatomy hasn't changed much since then, so it's still very relevant. The normal process of creating a surgical guide today, when the patient has teeth in their mouth, is to go ahead and to align the model of the STL to the patient's CT scan. And what we see on the screen is the line tooth functionality that we have in the software, where the user can place dots on the patient's model, as well as the panoramic CT scan, and the software goes ahead and it does that merge. So we could call this the standard way of creating a surgical guide, of merging its surfaces in order to create a surgical guide when the patient has teeth. And we also have the points functionality, which is another way of doing the merge if it's not going to be using the technique of marking the teeth. Here you could look for distinct and unique points that you could find on both 3D surfaces, place the points, and the software does the merge to align those two surfaces. And we'll be discussing that functionality today as well. But this is generally how it's done if the patient has teeth in their mouth. The challenge of creating a surgical guide for an edentulous arch is that there's no teeth. There's no teeth. There's no teeth for stitching the points. And of course, when you look at the CT scan of the patient's bone and you look at the model scan, which includes the gingiva, you don't have common surfaces where the points could be placed, and they're clearly not identifiable in order to do an accurate merge. So that's some of the challenges that we're facing with an edentulous arch. In addition, we need to know the future tooth positioning in order to plan the implants based on where the restoration is going to be. And we don't have that as well. In some situations, what we could do is we could segment the bone and create a bone-supported surgical guide. But in that situation as well, even if we create a surgical guide based on the bone segmentation and create a bone-supported surgical guide, we of course need to know the future positioning of the patient's teeth. So in order to properly treatment plan, we need to start with the creation of a proper denture to show us the ideal restorative endpoint. And here we see the process flow of the patient going through the steps of having a denture created by the lab with the proper phonetics, proper incisal edge position, proper facial plane, and we need to carry this through to create an actual denture. Not in the too distant future, we're going to be releasing a denture module to the Blue Sky Plan software that's going to help with a lot of this functionality. But the denture needs to be created either physically by the lab or in the future by the software. We need to know the final ideal positioning of the teeth, and we can't develop a definitive treatment plan until we have that proper denture. Once we have the denture, then we can go ahead and place the implants and know where the proper positioning and the proper treatment plan should look like. The dual scan technique, which is going to be the first procedure process that we're talking about, could be done by using the patient's existing denture. We could take the patient's existing denture and we could add markers to the denture. Blue Sky Bio carries the dental mark cone beam markers. You could see that a package of 110 markers could be purchased for $86. And these markers include a sticker surrounding the marker, which makes it easy to apply. And you have great looking markers that show up in this CT scan. So the process starts off by taking the patient's denture, if they have a proper existing fitting and functional denture, and adding markers to the patient's denture. The denture is then scanned in the CT scanner. If the CT scanner has a denture setting, then obviously you want to go ahead and use that. Some scanners come with an aluminum can that reduces radiation. You could try different settings and see what results in the best scan. So the denture is scanned on its own individually, and the patient is scanned as well with the denture and the markers in their mouth. When we scan the patient wearing the denture and the markers, we're going to get a CT scan that looks something like this. The denture itself is radiolucent, so when it's scanned together with the patient, it's not showing up. But the markers and the patient's anatomy is showing up in the CT scan. And when we're talking about the dual scan technique, we're talking about the scan of the patient with the markers, and we're talking about the scan, the CT scan of the denture with the markers as well. And in the software, we're going to go ahead and merge them. We're going to show the process in the software, and we'll be able to plan and create a surgical guide based on that. Now, what's really important is to make sure that the denture fits properly. Essentially, the surgical guide is the denture with the proper holes in it in the proper positioning. If the denture doesn't fit properly, then the surgical guide isn't going to fit properly either. The guide is not going to fit better than the denture. So if the denture doesn't have a nice, secure fit when it's placed in the patient's mouth, you should realign the denture with acrylic prior to scanning. Now, it's important to emphasize here acrylic. Acrylic is radiolucent, just like the denture is. So when they're scanned together, you're going to have good results. You don't want to be using a radiopaque material such as PVS. If you use that material together with the denture and scan them, you're not going to have a good render. You want to use consistent materials when you're realigning the denture. Okay, so we're going to see later on in the software how to see if it's not a proper fit or if the denture is not sitting properly. But it's important to emphasize this point from the get-go so that the denture could be realigned if needed, and we all make sure that the denture being used fits and secures nicely in the patient's mouth. Okay, now we're going to jump into the software and take a look at some cases. Okay, this is Blue Sky Plan. Oh, there we go. This is Blue Sky Plan. We're going to go ahead and start by loading a case for the dual scan technique. File, new project, DICOMs. We're going to select the patient scan. And the process flow of importing DICOMs was explained and described in more detail in the past, the shortcuts, the different ways of importing, the different capabilities the software has to import zipped and unzipped and compressed and uncompressed DICOMs. That's all been covered in the past, so we're going to move quickly through this process flow. Now we've imported the patient's scan together with the markers. Notice that now we're in advanced mode of the software. Recently, we've added this drop-down menu in the top right corner. You could switch quickly between modules. This is going to be also important when we roll out with the denture module. So we have the quick drop-down. Notice that now we're in advanced mode. We still have the usual drop-down from here as well. Just make sure you're operating in advanced mode. In normal mode, you won't have all of the capabilities and functionality that we're discussing in today's presentation. Now we're going to go ahead and import the CT scan of the denture. File, import DICOMs. Blue Sky Plan has the capability of importing different STLs and different DICOMs, and there's a slightly different process flow that the software takes you through depending on what you choose to import. Right now, we're going to go to import DICOMs for scan appliance, and we're going to navigate to the CT scan of the denture with markers. Okay, here as always, you can define your field of view. You can refine it by grabbing and dragging. I'm just going to go ahead and press OK. Now the software brings up a screen that looks a little bit confusing, but will be very clear in just a minute. What we're viewing now is the screen that allows us to merge the markers from the patient scan to the markers of the denture. And if you're using those markers that we showed previously, you're going to have well-defined markers, and the software will do the merge on its own. The software makes an attempt to do the merge on its own. Obviously, you need to confirm it and apply whatever changes or modifications in order to fix it. We'll discuss that in just now. But the software attempts to do the merge on its own. And if you're using clearly defined markers, you'll have a lot of success with that. The top left box that we see here is our patient scan markers. It's written on the top left. We have the density slider underneath each of the CT scans. We could go ahead and change the density threshold. If you don't see the markers clearly, then what you want to do is you want to raise the density threshold to remove the less dense anatomy and have the markers clearly defined. The top right is the markers for the scan appliance. Same thing, they should be clearly defined, no issues. You have the density threshold slider on the bottom as well. Let's go down to the bottom right view. And what we see here is the merge of the red markers, which are for the scan appliance, and the white markers, which are from the patient scan. And we're able to click the patient markers button or the scan appliance markers button and toggle them on and off. And using this functionality, we could clearly see the different markers and we could confirm our proper alignment. Now, if we don't have a proper alignment, then just first thing you want to do is raise those density thresholds and then click the update button on the bottom left. The software will reprocess and attempt a new merge. If that still doesn't get you a quality merge, then you want to help the software out. And again, if this is a situation where it doesn't merge properly automatically, the way that you're going to do that is by clicking the points markers functionality and hold down the shift key and left click on the markers themselves. And this is identifying for the software which components are markers, and it helps with the merge. Now you could mark all of them in one scan and then all of them in the other scan like I'm doing now, or you could go back and forth and mark one at a time. The order, the sequence, doesn't matter either. You could mark them in whatever sequence you like. Once you have this, you click the line points only checkbox, update, and again, the software will reconfigure and do a proper alignment. Now, in the bottom left box, what we have is our scan appliance. At this point, our scan appliance, our denture, is a CT scan. So again, we have the density threshold underneath. If you scanned it properly and the denture is a proper denture, then what the software is going to show you by default will be the patient's denture, and that won't need any changes to the density threshold or any modifications. If you do want to make some changes, then what you want to do is you want to lower the density threshold to the point where you have as full of a scan or as full of a denture as possible, but not to the extent that you now see a lot of scatter showing up in the denture. So you want to find that sweet point where it gives you full information without scatter. So that's the screen that we're looking at now. This is the screen to do the merge for the points. We have the patient's points in the top left. We have the scan appliance in the top right, the merge in the bottom right, and the scan appliance in the bottom left. Once we have the merge done in the bottom right, we go ahead and click the OK button. Now we just saw how the software aligns the denture to the patient scan. Let's open our surface panel and change the color just to make it a little bit more distinct. Okay, so the points fill the void of not being able to align teeth or not being able to clearly annotate particular points in the scans just like we showed at the beginning. When we had the teeth, we were able to use the teeth to help with the merge, and we were able to merge the teeth or find those clear points in both scans. As we discussed, the edentulous cases don't have that. So the markers are coming to fill that void and to give us that proper alignment between the two scans. Now we're going to mark the nerves as we proceed with planning this case. We'll go to the Add Nerve button, click Detect Nerve, click once on the entrance of the nerve. The software detects the nerve automatically, as we see. Go to the other side, Add Nerve. That we were on Edit Nerve. Let's go back and click Add Nerve. Yes, there we go. Detect nerve. Sorry, that's my mistake. And we go ahead and detect our nerves. So now we have the nerves in place, and we could go ahead and place some implants. We're going to select the Biomax Mini, proper jaw orientation. And what we're going to do here is we're going to switch over to the abutment panel and put in a custom abutment. We're going to make the abutments very long. And what this is going to do is it's going to show us our implant trajectory and the positioning of the implants coming through the denture. Right-clicking on the implant opens up a drop-down, and here we're able to choose Duplicate. And this provides good functionality to help with relatively quick planning, at least for initial positioning. And one of the benefits of this functionality is that once you position the implant or change the angle of the implant, and then you click Duplicate, the software creates a duplicate of the implant at the same angle. So at least for initial positioning, to help strive for parallel placement, you're able to use the duplicate functionality. Okay, what we can also notice here is our validation functionality. When you have a red exclamation mark showing up, then it's throwing a warning out to you. And if you want to see what the warning is, then click on the red exclamation mark, and it opens up our validation panel. And it says implant is too close to a nerve. So you're able to modify the positioning of the implant accordingly to take care of that. And the warnings that we currently have in the software regarding implants being too close to each other, or implants being too close to a nerve, or if the angle has an extreme deviation, then the software will throw those warnings. You're able to change the measurements for these validations, and you're also just able to turn them off. If you don't want to get a particular warning, you could turn them off as well. So we want to properly position these implants. If it's an overdenture, we want to make sure we have enough acrylic. If it's a fixed restoration, we want to plan properly for that as well. This isn't a perfect plan. You could go ahead and tweaking it and playing with it, but I think for now, for our purposes, we could go ahead and proceed using this. Okay, so now we've placed our implants. We created the long abutment. We've discussed the duplication functionality and the validation functionality. Now we're going to go ahead and create our guide. What's important to remember is that you need to turn on those software guide tubes. If the software guide tubes aren't visible, then you're not going to have a hole in the surgical guide at that location. In some situations, that's beneficial, and the user will want that. If they're creating a surgical guide without a particular osteotomy holes, they could hide the software guide tube. But make sure you have your software guide tubes on when you're going to create the surgical guide. We also have the drill kit dropdown, which allows us to select which drill kit that we want. Based on the implants that we placed, the software will show in the dropdown the relevant guided surgical kits. Those green semicircles that we see are the built-in drill stops for the Blue Sky Bio Direct cut drills. To create the surgical guide, we go ahead and we open the guide fabrication panel. We make sure that we have the correct model selected from the drop-down list. Okay, right now we only have one model, so that's not an issue, but we're going to see shortly, we're going to build up our list of models. So we need to always make sure that we're on top of the proper model, make sure that we're using the proper model. Now, when it comes to creating the surgical guide, we go to the button, Create Scan Appliance Guide. This will turn the denture into the surgical guide. This button is not there in normal mode, as same with some other functionality that we have in the panel that's also not available in normal mode. We're in advanced mode, so we have this button. And now we're going to create Scan Appliance Guide. Okay, let's take a look. Let's go to our surfaces panel. We now have a new surface called Scan Appliance Guide. Let's turn off the actual denture. And we see that the software has converted our scan appliance into our surgical guide. So it's really with the click of a button. We plan the implants, we click the button, and the software did the rest. The software converted the denture into a surgical guide. Now we have the ability, if we want to add a window, we could go ahead and right-click on the surgical guide and add a window. This isn't functionality that's particular to Edentulous guides, but it could be used here as well. And as I've described in the past, essentially what we're doing is we're placing this block where we want the window to be created. And then to create the surgical guide, with the window, we just go back to the guide panel and click Create Surgical Guide. Create Scan Appliance Guide. If you right-click on the box, you have different options of making it transparent, of duplicating the box to put in a different location. So you have different capabilities and functionality in order to create the windows in the surgical guide. We now have another new surface, and this box should have been placed slightly lower, but we see how the software removed the location of where that box is, and we could use it if we want to create a window in the surgical guide. For edentulous arches, we need to make sure that we reach the happy medium of creating a window without making the surgical guide too thin or too delicate in certain locations. Okay, so that's our create window functionality. Now, what I'm going to do is I'm going to go back to our original denture. Let's hide the implants, the abutments, and the software guide tubes. And what we're going to do is we're going to invert this denture. Okay. At the beginning of the presentation, I said that we're going to be discussing some of the functionality that we covered during the impression inversion webinar, and this is it. I'm going to go back and turn on our model manipulation panel, make sure we're working on the correct model, and we're going to draw I had the wrong surface selected, and we're going to draw the limiting curve. To do so, just hold down the Shift key, left drag, and we're defining the area or the software which we want to have inverted. Now, what this is going to do for us, once we invert the denture, is it's going to create our gingiva surface. Again, assuming that the denture fits and sits properly in the patient's mouth, then by inverting the denture, we should have an accurate representation of the patient's anatomy. I'm going to click Edit Curve. As usual, just want to make sure the points are positioned properly. Make any adjustments necessary. And then we're going to click Create Inverted Model. And this is going to connect as well as an introduction to the next process flow, which is the triple merge functionality. So the software is inverting the denture. And now if we go to our surfaces panel, we can see that we're building up the number of surfaces that we have here. Now we've created an inversion of the denture. We've created the gingiva, the anatomy of the patient. Let's turn back on our CT scan. And here we have the merge. We can turn on our implants, and we could see how the positioning of the implants and the abutments are in relation to our new model. We could go to the File menu and choose Create Analog Holes. And this created another new surface for us. And what this did is it created holes, the proper sizes and dimensions for the implant analogs to be dropped in to the model. Okay, we could see there's an inner diameter hole, there's a base with an inner diameter hole, so the analogs could be placed into the model, and then to remove them, you could stick a pin in or something and then pop them out from the bottom. So we have the functionality of creating a model for the implant analogs that we created once we had the treatment plan just by going to File, Create Analog Holes. Now we still have our inverted mesh that we inverted from the denture, which doesn't have the holes. The software saved that surface and created another surface for the analog hole models. Now, just for fun, we're going to turn back on our implants, our dentures, and our surgical guide. Sorry, our implants and our model with the software guide tubes, and we're going to go ahead and create a surgical guide. So we created a surgical guide based on converting the denture to the surgical guide. And now that we have the patient's anatomy, we could create, as a model, we could go ahead and create a surgical guide based on that. And that's going to, again, connect to the next process flow that we're going to present. Well, just as an exercise and demonstration, we're going to look and see if our surgical guides match up. So we need to be careful. We need to select the correct model. And now we're not using the Create Scan Appliance guide, but we're kind of using the same functionality as we would use when we were creating a model-based surgical guide. And we define our curve. Edit curve as always. Check the location of the points. Check that the curve looks okay. Now, if we did everything right, we expect that the surgical guide that were created previously will match the surgical guide that we're creating now. And again, there's no real need to create a surgical guide using two different techniques. This is more for kicks. It's more just to have fun using Blue Sky Plan. Now we're going to click Create Surgical Guide. You're able to choose the handpiece if you're using the Blue Sky Bio direct cut drills, and the handpiece is relevant in terms of controlling the drilling depth. So you could select the relevant handpiece and then click Save to create the surgical guide. Now, while this is functioning, okay, first let's check our surgical guides. Okay, so here's the denture guide that we created, the surgical guide that we created from the denture, and we see that in this tan color, and then we see the surgical guide that we just created after inverting the denture to create the model, and we see that it aligns perfectly. It aligns perfectly to each other and aligns perfectly to the software guide tubes. Now, we have also the option of creating an implant guide. And this is, again, unique to the Blue Sky Bio direct cut drills. You're able to create a second surgical guide. After you use the first one to create the osteotomies, you're able to create a second surgical guide for the implant placement. And that will control the depth placement of the implants, and creating it again is a click of a button. You have the surgical guide that you just made highlighted as the active model, and then you click Create Implant Guide. Okay, and we have another new surface that controls the placement, the depth of the implants when they're being placed using the ratchet. So now we have a long list of surfaces, and we're actually going to go ahead and make one more additional surface to demonstrate another functionality. And what we're going to do is we're going to create a surgical guide in order to create the holes in the denture, because we know the trajectory of the implants. Now, in order to properly create the holes in the denture to attach to the implants in the proper location, we could create a surgical guide on the denture itself. And in order to do that, what we need to do is we need to change the offset so that our software guide tubes are positioned much higher. So we're going to go ahead and increase the offset. This is telling us that we're making changes and need to be careful. But when we're creating the holes in the denture, depth is not important because we just go straight through. So I've changed the offset for the software guide tubes. I can click the button Apply to All, and it applies the change of the offset to all of the implants, to all of the software guide tubes. Okay, now what we're going to do is we're going to create a surgical guide to sit on top of the denture. And when we go back to our guide panel, we need to make sure that we're working on the correct surface, on the correct model. So we select our scan appliance guide, our denture, and now we're going to draw a curve just like we do when we create any surgical guide. Okay, edit curve, as always. Fine-tune positioning, no crisscrossed lines. So let's drop these down a bit. Okay, then we click Create Surgical Guide. And we have the surgical guide that goes on top of the denture. We could just drill through in order to create the proper location holes in the denture. So now we have our long list of surfaces, and what's great about Blue Sky Plan is you could export all of these surfaces from Blue Sky Plan with one export credit. Okay, it's per case. The export credits for surgical guides are per case. They're not per export. So you could export as many of these surfaces as you want from Blue Sky Plan with the same one export credit. We also added in a new button in the export panel. You can see that on the bottom left, a checkbox, export separated files to a folder. So in the past, you had two options, either to select a surface and do an export, save it, name it, save it, select another surface, name it, save it, and continue if you want different STL files. Or you could select multiple surfaces, export them, but then they're all exported as the same STL file. This checkbox allows you to select multiple surfaces or multiple components and export them to a folder on your computer, but instead of them showing up as a combined STL file, they're going to show up as multiple files. So that's a new button that we've recently added to Blue Sky Plan. Okay, so after we've created our long list of surfaces and did everything I think that we could do with this case, we're going to switch to another case. And the main point of this case is to demonstrate really two functionalities. it's not, the first one's actually not the functionality, but it's a point that we've discussed until now. We want to make sure it's integral that the denture sits properly in the patient's mouth. And we discussed that if it doesn't, you're not going to have a good surgical guide. And if it doesn't, then what you should do is you should realign it so that it does sit properly in the patient's mouth. But how do you know if the scan is problematic? Either because it doesn't fit properly or it wasn't seated properly. And we could see, if we look in the top right, in the top left, at our slices, at our cross-section slices, that towards the anterior, we don't see any space in our slice. Between the denture and between the patient's anatomy, we don't see any space. Let's go ahead and turn on the hint functionality so we see where the denture is. Okay, there's no separation. But as we move around the arch and go towards the posterior, we see the black separation. Okay, I'm pointing to the top left, to the middle image. The black that we see there is emptiness. It's space. It's air. There's no connection between the denture and between the patient's anatomy. So this surgical guide, as is, if we converted this into a surgical guide, then it's not going to sit properly. That's a very important point. It's a good way to confirm that the fit and the seating is done properly. Now, while we're discussing this, we do see that the merge is a good merge. How do we know that the merge is a good merge? Because the marker that we see here is the marker from the patient's scan. And we see that the denture outline wraps tightly around that marker. So the software merged the two scans correctly, and we see the merge is accurate, and that's a good way of determining if the merge is done properly, in addition to what we discussed earlier on the screen of the 4 different squares. The bottom right shows how shows the merge between the different markers. But once it's imported into Blue Sky Plan, this is a good way of confirming that the merge was done properly. The outline of the model should wrap tightly around the marker that was in the patient scan. So to summarize this point, we see that the merge was done properly, but we see that either the denture doesn't fit the patient or wasn't properly seating in the patient's mouth. Your question that just came in is a great question. And that's the next process flow we're going to discuss. We're going to show the triple merge technique. There are downsides to the triple merge technique. For example, you need to create the different components that we're going to discuss. You need to get them scanned, and there's more overhead in terms of merging everything together. Inverting the impression essentially accomplishes the same thing without pouring up the denture and without doing everything that we're going to be discussing. So both of them are good options. We're approaching the same thing from two sides of the same coin. The way that we're demonstrated impression inversion until now is one side of the coin based on the CT scan of the denture, then inverting it. In the next process flow, we're going to be demonstrating that triple scan technique, the triple merge technique. The last point that I want to demonstrate in this case is we've added some functionality to Blue Sky Plan. We could go ahead and replace these abutments to multi-unit abutments. And functionality that we have now, you could right-click on the implant and you could choose rotate around the longitudinal implant axis. Now the implant positioning is going to stay the same, but we could go ahead and rotate this so that we could get the prosthetic screw channel as parallel as possible to the other implants. Now once we have that with one implant, we could choose the functionality align with abutment prosthetic screw axis and then click on the one aligned already. And now the prosthetic screw axis of both of these multi-units are the same. Now our implant obviously is now out of whack. So we could rotate around abutment prosthetic screw axis, and we could keep the prosthetic screw axis in the same location, and we could rotate the implant around that. So that's relatively new functionality that we have in the software as well. The different options of aligning the prosthetic screw channel and rotating either around the prosthetic screw channel, around the implant axis, or a combination of those. Now, once we have everything that we have, everything that we've had created, in order to convert it to a real physical guide, we've added in new functionality into Blue Sky Plan called the Lab Pronto. Lab Pronto, you're able to place an order for your lab products, digital and physical. The order gets sent out through a qualified network of dental labs. The lab that has the order, the lab that has the time to deal with the order immediately claims the job and turns around the order. Now, dentists that have tried this out are amazed with the turnaround time. If it's a digital product, you'll see you place the order within a very short amount of time. You get a notification your order is being worked on, and then shortly thereafter you get the digital files uploaded back to you. If it's a physical product, then of course the turnaround time is longer. It needs to be shipped back to you, but the order is claimed and the order is done very quickly. So we have the Lab Pronto button that's in the horizontal toolbar. The services that are currently being offered are treatment planning, which is Pronto Plan, surgical guide, fabrication, that's for the physical guide, ortho plan, aligners, and bone segmentation. So any of these services, with a click, you could upload the files. The files are automatically attached to your order. If you have the case open in front of you, you finish the plan, for example, now you want to order the aligner, you press the Lab Pronto button. The files of the case that's open are automatically attached to the order. You select the exact service that you want, what type of surgical guide, you put in any comments, notes, specifications, and you press the Order Now button. You can see a 4-implant case similar to what we just planned. If you want to convert that into an actual surgical guide, you do it with the click of a button. It gets sent out, done, turned around very quickly with great service. Okay, the second technique that I want to discuss after the dual scan technique that we presented until now is our triple merge technique. And the triple merge that we're talking about is the CT scan of the patient wearing the denture, the CT scan of the denture with a poured base, and the CT scan of the poured denture, which is essentially the gingiva. The middle scan, I put in parentheses bridge, the middle scan is there to correlate the positioning between the patient scan and the poured denture scan. Okay, we have no points, as we've been discussing, we have no points common between that first scan and the third scan, but when we introduce and use that middle scan, we do have common points. Now, this process flow requires the duplication of the denture. It depends on a very nice and accurate duplication of the denture. Corey's presented different ways of using a standard lab appliance box to create a clamshell impression, to pour it up, and to create the denture. So this going back to the question previously, this requires a bit more prep, a bit more overhead, and a bit more merges, but it's a great process flow as well. It all depends and all starts with the duplication of the denture. Okay, the denture duplicate can be created using the annexdent material. And once the denture is created, we pour up the denture to create, essentially to create the inverted impression, just like we presented earlier. but we're creating the anatomy, we're creating the gingiva of the patient. We add a base to the poured up denture, to the reline, and the goal of the base is to have markers in the base. Now, when we scan this, we're scanning this not with a CT scanner, we're scanning this with an STL optical scanner. When we scan this, we're going to be able to use the markers in the base to align it to the scan of the patient. We go ahead and we scan, oh, let me just jump back. We go ahead and we scan everything together. And then we go ahead and we scan the poured up denture with the base together. Now we're going to take a look at it in the Blue Sky Plan software. Okay, this is our patient scan that we just saw on the slides, and this is including the patient wearing their denture, and all of that is scanned together. Now we're going to import, that's our first scan, we're going to import two additional scans. And now we're going to go to File, Import STL Model. We're not importing DICOMs, we're importing an STL model. And we're going to check denture with base. And we're going to click OK. Now, when you import an STL model, the software automatically defaults to the functionality to align teeth, to mark the teeth in both scans, and to go ahead and do that merge. That's not what we're going to be doing now. We're going to click Cancel. And instead, we're going to be switching to the points alignment, and we're going to click Align. This is the functionality that we touched upon previously, where we're going to mark unique points in both scans and do the merge that way. Now, the advantage here, because we have markers both on the denture and on the base, our alignments and our merges are much, much easier. We have clearly identifiable points. So we're going to hold down the Shift key, left click, and we're going to select the markers in both of the scans. Okay, we have a surplus here of markers. We don't even need to use all of them. Take a bunch of them, click OK. We should mark 5 or 6 points. And here we have the merge. We've just merged the patient CT scan to the model scan of the denture that includes the denture pour-up as well as the base. Let's turn off for now. Okay, so we have our first merge done, and we have two surfaces. Now, this does not give us the gingiva base. This does not give us the patient's anatomy for surgical guide fabrication. So we're going to import our third surface and merge that as well. We go to File, Import STL Model, and we're going to choose the base. And again, we cancel out the default alignment. We're going to switch to points. And we're not going to click Align. We're going to click Align to Model. Align is to align to a CT scan. If you want to align an STL scan, an optical scan to an optical scan, then you click Align to Model. Press the OK button. And now we have our two optical STL scans. And again, the merge now is easy because we have clearly identifiable points. We're not going to be using the points on the denture. We're going to be using the points on the base. These points in this situation are impressed into the base. We could use the glass markers, or we could use a technique similar to this one. They both work just fine. Okay, we're holding down the Shift key, we're left clicking, and we're placing the markers on both scans. Once we do that, we go ahead and press OK. And we have our different surfaces. Let's take a look at them. This is our poor denture, the gingiva. This is the second imported optical scan. This is the bridge, because you remember the first merge that we did was the CT scan of the patient with the denture to this bridge. And then the second scan was using the markers on the base of the bridge to align the poured denture, the gingiva of the patient. So now what we have is the CT of the patient, and we have a surface that we could use to make a surgical guide. Okay. This case is clearly already treatment planned. And just to note, we have the fastening pins in place. To place a fastening pin, you go to the Add Implant button, switch over to the pin section, click OK, and then you left click in the position where you want to drop the pin. And that pin is going to be placed horizontally into the plan. And you can see that the pin positioning is between implants. We want to make sure it goes into the bone, not too far into the bone. Just to touch upon the pin functionality, we have the software guide tubes. The software guide tubes are placed for the implants and are placed for the pins as well. If we switched to a different guided surgical kit, then we wouldn't have those green semicircles. Instead, the positioning of the software guide tubes would be more flush to the head of the pin. And if I turn the green semicircles back on by going to the drill kit for Blue Sky Bio direct cut drills, then we could see that now the software guide tubes are positioned a bit farther away from the patient, but the built-in drill stop is smaller. If we wanted to move the software guide tubes closer to the patient's anatomy for the surgical guide fabrication, then we could go ahead and decrease. In this situation, we're decreasing the offset to move it closer to the denture and to the model. And we could see that as we decrease the offset, the built-in drill stop increases automatically. Let's just do that to demonstrate it again. Okay, the software guide tube moves closer and the built-in drill stop increases. Now, these fastening pins are the same length as the Blue Sky Bio direct cut short drills. So if you're using the short drill to create the hole for the pin, the drill will bottom out at the exact depth, and you'll be able to insert the pins with no issues. Okay. Let's go back to our surfaces panel. To create the surgical guide now, what we want to do is not use the scan appliance guide functionality, but we're going to use our normal functionality to create a surgical guide from an STL model. We're going to make sure we have the correct model selected. We're going to click Draw Curve. Edit curve. And create surgical guide. Now, while this is being presented in this situation with the Blue Sky Bio direct cut drills, from the implants panel, you could select any guided surgical kit. You could place any implant system, and then the drop-down will show you the relevant guided surgical kit for that implant system. Okay, so now we've created our surgical guide, and we're using the model, we're using the STL surface that we imported into the software by using that bridge, by using the second surface that included both the denture and the poured up denture and the base. Just to summarize, the first scan that we imported was the patient scan with the denture. The second scan was a bridge scan that included the components of the denture, the poured denture, and the base. We merged that scan and aligned it to the patient scan by using the points on the denture. And then we imported our third scan, which is the poured denture representing the gingiva of the patient, and aligned it through the indentations that we have in the base. Okay, so I think that's the topics that I wanted to cover for today's presentation. If you missed some of the points or want to view the process flow again, so the presentation is being recorded, it will be available on YouTube and the Blue Sky Plan website. So you're definitely encouraged to watch it, to share it, to see it again, to review it. And if you have any questions, as always, you could contact us at plan@blueskybio.com. The phone number is underneath that for support. My contact information is on the bottom right. The Blue Sky Bio user group is a valuable resource. It's monitored by Blue Sky Bio, and it's monitored by a lot of very capable and dentists who are very generous with their time. If you have any questions, really the fastest way of getting a response is by posting to the group and getting answers and support that way. You could always learn more via the blueskyplan.com website. We have an education section, which is really full of courses, full of recorded webinars. There's really a frequently asked questions, step-by-step tutorials. There's a wealth of free information that can be accessed by clicking on education in the top horizontal header on the blueskyplan.com website. Of course, don't forget to enter your details into the webinar attendance form. The link is in the chat box, so we can send you the CE credit. It usually arrives via email within 1 week of the presentation. I'd like to thank everybody for taking time out of your busy schedules to join us for the presentation. Upcoming webinar presentation schedule is available on blueskyplan.com, as are the recorded webinars, as are information regarding live courses with our partners. Are there any scan dummies or archives for practicing? I could upload these cases actually to the blueskyplan.com website and make them more accessible for practicing. Meanwhile, you can also email me, and I can email to you before we get that set up on the website. Thank you very much. Enjoy the rest of your day.